All right, so let's look at these problems in a slightly different manner. Okay, here we are going to be determining the mass of sodium chloride produced when 1.25 moles of chlorine gas reacts vigorously with excess sodium. Okay, so I'm going to first go ahead and before I ask anything about the problem, make sure that it's balanced. So if I look at my equation here, I've got 1 sodium on my reactant side and 1 sodium in my product side. I've got 2 chlorines in my reactants and only 1 in my products. So I'm going to put a 2 coefficient so that I fix my chlorines, and I've got 2 chlorines and 2 chlorines. However, now in my product side I've got 2 sodiums and only 1 in my reactant, so to fix that I'm going to put a 2 here. Okay, so my balanced equation is 2 sodium, 1 Cl2, and 2 sodium chloride. Okay, alright, so let's look at the problem. Okay, remember to look for a number, unit, substance. That's going to be what information you are being given, or something that maybe you should start with for your conversions. Okay, so let's determine the mass of sodium chloride produced when number, so 1.25 moles, that's our unit, of chlorine gas. So I know that I've got 1.25 moles of chlorine gas. Alright, so I know this. Reacts vigorously with excess sodium, and that just means that there's plenty of sodium left over. And we'll actually, again, define this term later. So what I'm asked to find is to determine the mass of sodium chloride. So I'm looking for the mass of sodium chloride. Okay, if I have 1.25 moles of chlorine gas. So here I start with moles, and now the reason this problem is different is because I'm actually being asked to find mass of another substance, not just a mole-to-mole conversion. Alright, so this is why it's slightly different than the ones that we've looked at before, but we work it the same as far as our method goes. So I'm going to start with my 1.25 moles of chlorine gas, which is Cl2. Okay. I know that I don't want to talk about moles of Cl2 anymore, so I'm going to have to do some dimensional analysis. To cancel out moles of chlorine, I'm going to write moles of chlorine at the bottom, or in the denominator. Alright, and I know that that will cancel out moles of chlorine, so I've canceled my unit and substance. Okay, the only thing that I can do if I've got moles of chlorine here in the denominator is either find other information like mass or particles of Cl2, or I can use the mole ratio using my balanced chemical equation to get out of chlorine and into, say, the substance that I'm being asked to find, sodium chloride. So here, I know that I can use my mole ratio, so I'm going to go ahead and say if I'm getting out of moles of one thing, I can get into moles of another. That other thing I'm asked to find is sodium chloride. Okay. And right here, this would leave me with the units moles of sodium chloride. However, I've been asked to find the mass. So since that's not what I want to find, I'm going to do some more dimensional analysis. I don't want to talk about moles of sodium chloride, so I'm going to write moles of sodium chloride in my denominator so that they cancel out. Okay, and I know that if I have moles of sodium chloride, I can find the mass using molar mass. So I've got a relationship between moles of sodium chloride and grams of sodium chloride. So we see here, using our conversion factor, we have converted out of different units and substances and into a new unit and substance. Okay, grams of sodium chloride, that is my desired unit and substance. I'm going to go ahead and write that information in my answer. Okay, leaving room for a number. Then I'm going to go back and fill in the information that I need and do my calculation. Okay, to me, the mole ratio is always the first part of my dimensional analysis problems, the first kind of ratio or conversion factor that I will fill out, because I know I definitely don't have to ever do calculations because it comes from the equation. So here I need to see how many moles of sodium chloride are represented, which is 2. So there's 2 moles of sodium chloride represented for every 1 mole of Cl2. Okay, so it's a 2-to-1 ratio. Alright, this conversion factor is complete. I need to now look over here. I've got moles and mass, and the only way to convert between moles and mass is the molar mass, and this is for sodium chloride. So I've got to calculate the molar mass of sodium chloride. Okay, I'm going to do that by taking the mass of sodium and the mass of chlorine. Okay, sodium, and remember we get these from the periodic table. Okay, sodium's molar mass is 22.98 or 99. It doesn't really matter. We'll do 99 since we've been rounding the same. So 22.99 grams per mole. Chlorine is 35.45 grams per mole. Okay, sodium chloride has a 1-to-1 mole ratio of sodium and chlorine. So I've got one of each of these. If I add them up, that's going to be the mass of 1 mole of this compound, sodium chloride. Okay, so this is a Sunday, so I'm not going to do mental math right now. And yes, that makes a lot of sense, 58.44. A lot of times you'll get 58.43. Doesn't really change your answer much. You would have gotten 58.43 if you kept that rounded to 98, which is what I usually do. Okay, this here means that if I'm talking about sodium chloride, there's 58.4 grams of sodium chloride in every mole of sodium chloride. So I can use this grams per mole to say there's that many grams in 1 mole and write that up here. So there's 58.44 grams of sodium chloride in every mole of sodium chloride. Okay. Now that everything is complete, I've got the answers I want, I can do the math and I will be done. Okay. So here I'm going to take 1.25 moles of chlorine, multiply it by this mole ratio, which is going to be 2/1, or just take 1.25 times 2. That's going to be 2.5, but we'll just practice. Okay. And then I'm going to multiply it here by 58.44. Okay, this gives me 146.1 grams of sodium chloride produced. Okay. So this means that as long as I've got plenty of sodium to react, if I have 1.25 moles of chlorine gas, I should produce this mass of sodium chloride. Okay, that's the problem.